Hello everyone, so my name is Vedant and today we will be discussing Codeforces Round 1080 Div 3. And yes, today's contest was pretty hard. So let's start. Alright, so the first question is sieve of, you are given n positive integers a1 to an. Please determine if it is possible to select any number of elements in A so that their product is 67. Note that you may not select zero elements, as the product of zero elements is not defined in this problem. And we are given up to 5 elements, and the elements have values between 1 and 67. And number of test cases are up to 24. Okay, so basically, in A part, we need to select some elements, let's say P1, P1, P2, P3, and their product should be equal to 67. Now, if their product is 67, then definitely all of these must be 67's factor as well. Now, if we write the prime factorization of 67, we actually find out that 67 is a prime number itself. And its only factors are 1 and 67. So to create 67, all we have to do is select a 67. So if A has 67, then answer is yes. Else answer is no. Right? And we can see the test cases. In the first test case, we have 67, so answer is yes. In the second, we don't have 67, so it is not possible to create it. Okay, so let's check the code. So since n was very small, I just sorted the entire array, and if the last element is 67, then our answer is yes, else our answer is no. And we only need to check the last element because we know that the maximum value for any element can be 67 only according to the constraints. So let's move on to problem number B. Problem B is heapifier. So you are given a permutation A of length n, and you can perform the following operations any number of times. Select an index I from 1 to n by 2. That is, we need to select from the first half and swap and swap AI and A to Y. For example, in this array, we can swap A2 and A4, but we cannot swap A2 and A3. And we need to determine if the sequence A can be sorted. Now we know that A is a permutation, so all elements are distinct, obviously, and n is up to 2e5. So either an O of n or O of m log n should work. So let's check this. All right, so B. So basically, when a permutation is sorted, so let's say n is 8. So our array will be 1, 2, 3 up to 8 in ascending order, right? Like this is our array. So we would be given some permutation. If we need to tell if we can convert that permutation to this array or not. So if we notice, we can't really swap any elements. There is a constraint on the swapping, right? We can swap A1 with A2, and we can swap A2 with A4, and we can swap A4 with A8, and so on if n is large. Similarly, we can swap A3 with A6, and I'll just write for a common n, right? A6 with A12 and A12 with A24, and so on. And similarly for A5 also it is like this only, A5 to A10, then A10 to A20 with A20, and so on. And we can say that we can do this for all numbers that are left. For A7 it will be start with A14, and further with A21. Now if we notice one thing in this element, what we are doing is we are swapping some AI. We can swap some AI with AJ, right? AI and AJ can be swapped, but there is some constraint on it, right? So if we notice the constraint, we can swap A1 with A2, then A2 with A4. So we can also swap A1 with A4 and A1 with 8 as well. Similarly, we can swap A3 with A12 or A3 with A24. So what we are noticing is if we have a certain AI, we can swap AI with any AJ if J is a multiple of I. And also J is of the form of some power of 2 into I, right? Let's say we can only swap if J is equal to some 2 raised to x into I, right? And here what I'm saying is I is less than J. Else the condition is only opposite, right? We are anyway swapping with the smaller, we are swapping the smaller number with the larger number anyways. Like we can see here also, A5 is swapped with A20 and 20 is nothing but 5 times 4. A7 is swapped with 21. Oh, sorry, this is wrong. A7 is swapped with A28. My bad. So again, A28 is nothing but 7 times 4. So basically, what we can see is, for example, if all we need to do is keep dividing j by 2, and if j becomes equal to I, then swap is possible. Else swap is not possible, right? So now we know which all elements can be swapped. So if A1 cannot be swapped with A3, that means that if a final number has a position of A3, like the third position, then it cannot be present at any position like A1 or A2 or A5, right? So what we can notice is that uh, like if we take out the elements in these forms, like we create a separate array for these elements A1, A2, A4, A8, separate array for A3, A6, A12, and then we can sort all of these, and if we combine them back, if then our array is sorted, then it is possible, else it is not possible, right? But we can see this in one more way. We already know that the elements of A1, A2, A4, A8, final elements are 1, 2, 4, and 8 only, right? So that means if like our index is I, suppose, and our element is AI. So this will fit our swapping constraints only if like suppose we instead of dividing j to convert it into I, what we can also do is here is we can divide both j and I, right? We can keep dividing both j and I, and it will be reduced to some number that cannot be divided further. For example, here let's say we have the sixth element and the 24th element. So if we divide 6 by 2, we get 3. If we divide 24 by 2 three times, we again get 3. 3 is not divisible by 2 further, and 3 is equal in like for both the of them we are getting the same number. That means A6 and A24 can be swapped, right? So what I'm saying is if uh, we keep dividing I and AI, like I is of some form 2 raised to x1 into z, and AI is of some form 2 raised to x2 into y. So if this y and z are equal, then it is correct, right? Then it is correct. Else it is not possible. Else it is not possible, right? So any doubt? Yeah, we can also say that we just divide these two elements and it should be a power of 2. It is one and the same thing only, right? Actually, I submitted wrong answer on AI. Read the question wrong. I thought we need to, we have to select two elements and product of two elements should be 11. Sorry, 67. So I was finding both 1 and 67. Then later saw that I have submitted it wrong when I submitted for question 2. All right, I'll explain again. So see, we have 1 minute. So did you understand the part where we can only swap A1, A2, A4 and A8. Similarly, we can only swap A3, A6, A12 and A24. We can't swap A2 and A3. We can't swap A2 and A12. Right? Is this part clear? Zerif Gamer. So once we know that which all elements we can swap together, what we know we can only swap these elements together. And we also know that in these indices, one like for A1, A2, A4, A8, our elements should be 1, 2, 4, and 8 only, right? We cannot have some element except 1, 2, 4, and 8 for A1, A2, A4, and A8. We can't have a 3 in these. We can't have a 6. 6 should be somewhere in A3, A6, A12, or A24 only. So what I'm saying is that if we pick up the both index and like we have a index I and the element AI, both these elements should be of the form like some 2 raised to x1 into z1, and this is of the form 2 raised to x2 into z2. So this z1 and z2 must be equal. We need to satisfy this condition, else it is not possible. Because here if we see, like if we pick up these two elements, 6 and 24. So 6 is of the form, like I'll write this down only. Like 6 is 2 into 3 and 24 is 8 into 3. So we can see that these are equal. So these can be swapped. But if we pick 18, 18 is 2 into 9. So 6 and 18 cannot be swapped. Right. So what we need is that if these elements are equal after removing the power of 2, then we can swap it. Or you can also say that if we divide these two elements, like someone pointed out, like if we divide these two elements, like if I is greater than AI, then I by AI should be a power of 2. Power of 2. Or else AI by I should be a power of 2. If that's the case, then it is good. Else it is wrong. Brute force can be implemented for second, I guess, as sorting independent sets. Yeah, yeah, we can take out all the sets and sort as well because the constraints are If we take out all the sets and sort, it is, as you said, n log n square only. So that will also work. So that number is a property for a number, which means that it can be swapped or not. And all that remains to check the integer. Right, right. We know which all numbers can be swapped together. So we just need to ensure that the correct element is placed in the correct set. Bro, what if we take XORs of all the indices and the elements at last? It should come out 0. What if we take XOR of all the indices and the elements at last? You mean we should take out the XOR like in the starting only or after sorting? Like what exactly do we need? Are you saying? Like for example, if we take the test case, actually I think B is clear right now. Like we can do either way, either divide both the elements and check if these are equal or like divide both the elements independently by 2 and check if they are equal, or divide them by each other and check if it is a power of 2, right? And let's check the test case as well. In this test case, 1 is mapped right. Now this is 4 and the index is 2. So 4 by 2 is 2, which is a power of 2, which is also correct. Again, 3 by 3 is 1 is also correct. Now this is 2 and the index is 4 to 2. Then 2 by 4 is also correct. And here 5 is also correct. Now if we check this one here, 2 is on the third index. So 2 by 3 or 3 by 2, whatever you say, like it is not a power of 2, right? Here we also need to make one more check. I modulo, like for this one, I modulo AI should be 0. And for this, AI modulo I should be 0. Right. This is clear, right? So let's check the code. So I actually implemented the first approach I told. Like we'll divide both the numbers by their highest power of 2, and then we'll check these numbers. And there is a like a cunning way to find out the highest power of 2. Like suppose we have a number x. So if we take out x and minus x, this is actually the highest power of 2 dividing x. So like we have index I and element ai. So we need to check whether I upon I and minus I is equal to ai upon ai and minus ai. Like we can do this normally also with the while loop, but I just use this short trick. So as you can see, we are iterating, and then if these two are not equal, then the answer is no. And if for all elements they are equal, then the answer is yes. So now let's move on to question number 3. Dice roll sequence. Consider the following cube D, where the number x and 7 minus x lie on the opposite side. So this is a standard dice. 1 and 6 are on the opposite end, 2 and 5 are on the opposite end, and similarly 3 and 4 are on the opposite end. Like 1 and 6, 2 and 5, 3 and 4. These are on the opposite ends. A sequence B of integers from 1 to 6 is called a dice roll sequence if it satisfies the following condition. All pair of adjacent elements lie on the adjacent side of cubes. For example, 1, 4, 2 is a dice sequence while 3, 4, 6, 2 is not. Because 3 and 4 are not on adjacent side. We know that 3 and 4 are on the opposite side, right? Additionally, 2 to 4 is not a dice roll sequence because 2 and 2 are on the same side. They are not on the same side, they are the same numbers. And given a sequence A of n integers from 1 to 6, We can perform the following operations any number of times. Select an index and change the value of that index to some other value. And please determine the minimum number of operations required to make a dice roll. So what we need to do is we are given an array and we need to check if it is a dice roll or not. Like make this make this into a dice roll sequence. Right. In minimum operations. And what do we know? Like, what is a valid dice sequence? So, a valid dice, let's say we have two elements, AI and AI minus one, like two adjacent elements. So, basically, like AI and AI minus one should not be equal. They should not be equal, right? And also, their sum should not be equal to 7. Like, are these two conditions, like, these are the only two conditions, right? As we can see, 1 and 6 cannot be together, 5 and 2 cannot be together, 3 and 4 cannot be together, and their sum is 7. So now let's see examples once. So our first example is 142, and we can see this is a valid sequence. In our second example, we have 3, 4, 6, and 3. 3 and 4 cannot be together, so one of them needs to be changed. Let's say we change 4 to 2. So 3 and 2 is valid, 3 plus 2 is 5. 2 and 6 are also valid, 6 plus 2 is 8, and 6 and 3 are again valid. And in the third case, actually, let's see the third case later on. Actually, third. Yeah, I'm discussing third, then I'll read the comment. Yeah, so basically we need to do this. And we also know that if if this is not happening, then need to change an element. And since we are checking AI and AI minus one, we need to either change AI or AI minus one. Now let's say we have this like we have a AI and actually let's not write AI right now. Let's say we have an element X and we have an element Y here and Z here. Let's say these two elements are causing trouble. Like let's say y plus x is 7. So either change y or x, right? Now we will have a big sequence. Like let's say here we have another element. Like we have p, q, and then we have w, v, s, t, some elements. We know that q and y are not causing any problem. Like no issues. No issue. Why I'm saying Q and Y are not causing any problem because we are iterating from left to right. So we would have probably handled this, but we don't know about these two elements. Don't know. Right. So X XZ might cause a issue. So if we change X, isn't it better? Because we already know Y is not causing an issue with Q. So if we change X, Y won't cause an issue with X either. And X might be causing an issue with Z as well. So in that case, both of them will be solved together, right? So might be causing an issue. Like let's say we have x equals to z. Like we have both of these conditions. So change x. And even if this is not the case, x is not causing an issue with z. We have, if we change x, we have five possible values, right? Except x. Like let's suppose y was 3 and x would have been 4. And let's say z was let's say z was maybe 1, right? So we know that 4 was causing trouble. Now, if we change x, what can be the possible values? Like, we can change x to any value, right? Now, if we choose 1 will also cause trouble because then it will be equal to z. We can choose 2. 3 will also cause trouble. We can't choose 4. We are changing x was 4. We can choose 5. And 6 will also cause trouble. So, we will always have at least two values that we can change x into so that x won't cause trouble with y as well as z, right? So what we can say from this is if ai and ai minus 1 have some issue, change ai, and this will also ensure no issue with ai plus 1. So what we can basically do is we can just loop through this easily, and whenever we'll find an element with which we are having an issue, we'll change that element, and then the next element will also be automatically solved, right? So let's try this on the test case. Here, like we need to check the element with its previous element, so we will skip the first element. Now our second element is 1. 1 is causing trouble with 6, so we will change 1. Since we are changing 1, we can change 1 to something so that it won't cause trouble with 4. For example, we can change 1 into 2. So we can now skip 4. Now 3 is causing trouble. So we can change 3. And we can change 3 into anything so that it won't cause trouble with 1 either. So we'll skip 1. Now this 3 is not causing any trouble with 1. Then 2 is not causing any trouble. Now 5 is causing trouble. So we need to change 5. And then we can skip this 4. And now 4 is causing trouble because both these elements are equal. So we need to change the last 4 as well. So that's how we need to change the 4 elements here. So, like, is the approach clear? Like, the question was basically greedy. There could be other methods as well, like DP or something, like you guys were saying in the comments, but this greedy approach is pretty directly. So if we change AI automatically fixes AI plus 1. Yeah, exactly. Because we have 6 pair values, right? And AI minus 1 is only stopping us from 2 possible values. And similarly, AI plus 1 will also stop us from 2 values, right? So in any case, we will have 2 values left with which AI won't have any trouble with AI plus 1 as well as AI minus 1. In B, I just ran the swap if x is greater than y for valid indices 1,000 times and after check. Yeah, maybe in 1,000 times it would have been able to like do all the possible swaps. Like we'll know if it gets hacked, right? Can you please tell where I'm going wrong in this logic? The min frequency. of x comma 7 minus x and summing up for 1, 2, 3. Uh, I don't exactly understand what exactly is the logic for this. My greedy solution got accepted. It only changes the AI minus 1, AI and AI plus 1. Greedy approach. It is a DP problem. You could probably solve it with DP as well, but it is not needed. Yeah, it does change our future decision, but the thing is, if we are changing AI, we can just skip AI plus 1. So this is how we are avoiding a DP. Greedy approach in the sense checking minimum frequency of x, comma 7 minus x and summing up this for 1, 2, and 3. So I think you got a different approach from mine. So DP is not the only way for this. We can solve this greedily as well. Yeah, so I don't think there is any doubt, right? So let's go on the code. So yeah, the code is pretty straightforward. We are only checking if AI and AI plus AI minus 1 are equal to 7, or these both elements are equal. Then this there is issue with this element, right? So we are increasing the count. Count is the number of like operations we need to do, and then I am incrementing I. What exactly this is doing is this is skipping the next element because I'm incrementing I once inside the loop, and then when the loop ends, I is incremented again. So AI plus 1 is skipped, and that's what we need to do, right? Because AI plus 1 is automatically fixed. All we are doing is we are checking the current element with this previous element. We don't care whether it is having an issue with the next element or not, because we'll solve that issue when we'll check the next element. Yeah, so let's go on to D. So it is absolute cinema. There is a hidden sequence A1 to AN of n integers, n is at least 2, and it is guaranteed that the mod value of AI is less than 1000, less than or equal to 1000 for all values of I from 1 to n. Let's define a function fx as follows. Fx is summation of AI into mod of I minus x over all values of I. Given n values f1, f2 up to fn, please determine a1 to a1. A1 to an. It is guaranteed that the values of a1 to an can be determined uniquely. And our n is up to 3, 5. So basically, this is another problem with either O of n or O of n log n. Like this is the most common complexity, right? And our values of f can go up to minus 1e4 to plus 1e4. And okay, now let's see what exactly we are given here. So what we are given is fx is equal to summation I from 1 to n ai and mod I minus x. So we can open this up to like we won't have ax element, right? So let's say ax plus 1 plus 2 ax plus 2 plus 3 ax plus 3 and so on. And similarly this side also we'll have ax minus 1 plus ax minus 2 plus ax minus 3 and so on. Now let's also check fx minus 1 because like we have n equations anyways, right? And we need to do some form of arithmetics on these equations. So let's just check what's up with fx, or let's check fx plus 1. So fx plus 1 will be now x plus 1 will not be there, right? So it will have plus ax plus 2 plus 2 ax plus 3 and so on. and here we will have ax. So this element is different. Plus 2ax minus 1 plus 3ax minus 2 plus, oh sorry, I forgot the coefficient, plus 4ax minus 3 and so on, right? So what we can notice is that except these two elements, if we ignore these two elements, or actually let's not ignore these elements either. For some elements, fx has one coefficient more than fx minus 1, and for other elements, fx plus 1 have one coefficient more, right? So let's say we subtract them. Fx plus 1 minus fx. So what we'll get? Or let's do the opposite subtraction actually. Fx minus fx plus 1. Let's do this. So what we'll get with this? All values from ax plus 1 and forward will have a plus 1 coefficient, and all values from ax and below them will have a minus 1 coefficient, right? So what we can write is like ax plus 1 plus ax plus 2 plus ax plus 3 and so on, minus ax plus 2 plus ax plus 3 and so on, right? And well, we can't exactly solve with this either. All we have is all elements with a plus 1 or minus 1 coefficient. Now, so earlier what we were doing was we just took two elements, fx and fx plus 1, and we were checking if there is some connection between them. Let's do the same again. Now, let's write fx plus 1 minus fx plus 2. Or actually, instead, let's write fx minus 1 minus fx, like the previous element. Like if we replace x with x minus 1, that's all we need to do in this, right? So we'll get ax plus ax plus 1, and so let's write some more terms, minus ax plus 1 plus ax plus 2 plus ax plus 3 and so on, right? So we have these two expressions, and these expressions are pretty similar, I would say. What happens if we subtract these expressions? Everything beyond ax plus 1 is the same. Here ax will be left. Like, right. And similarly, everything beyond this is also same. Actually, it is getting a bit confusing with x. So instead, let's write this in form of, like, let's just write what is f1. Like, let's just replace x for now. Like, let's f2 minus f1, and let's also find out f3 minus f2. So if we replace the values here, so yeah, let's just replace in this. Oh, my bad. I wrote this. F1 minus f2 and f2 minus f3. Like, let's find this out. So if we replace x with 2, we'll get what we'll get? A2 plus A3 plus A4 and so on minus A1. Actually, I wrote this expression a bit wrong also. These were elements smaller than x, right? So this was x, this was ax minus 1, and so on. Yeah, let's just check this once. So we are subtracting fx and fx plus 1. So all elements from ax plus 1, ax plus 2 will have a positive coefficient, and ax minus 1, ax minus 2 will have a negative coefficient. So right, ax minus 1, ax minus 2 will have a negative coefficient. So here also when we are replacing x with x minus 1, so these will have negative coefficients, right? Ax minus 1, ax minus 2, ax minus 3, and so on. So now we need to subtract these. Yeah, let's rub this. Yeah, so these are our two expressions. So we can see that ax plus 1, ax plus 2, ax plus 3, and so on is also present in the bottom expression. Like this whole term is here. And then ax minus 1, ax minus 2, and the further terms are present here. So when we subtract these two, what we'll get? Fx plus 1 plus fx minus 1 minus 2fx will be equal to 2ax. Or we can say ax is equal to fx plus 1 plus fx minus 1 minus 2fx by 2. Right. Explanation. How the previous one explained. So do you have doubt in problem D or problem C? Like, should I repeat this derivation for problem D? Like, I'll repeat this if something is not clear. Like, this is a bit math heavy. So, Kusha is saying it's good. So, I'll just repeat it a bit once. So, basically, we are given the expression for fx, right? So, if we expand this, what we know is that ax won't be present, and all terms from ax plus 1, ax plus 2, ax plus 3 will have an increasing coefficient. Similarly, all terms smaller than that, ax minus 1, ax minus 2, ax minus 3 will also have an increasing coefficient. So now what we need to do is we are given n such equations, f1, f2, f3 up to fn, right? And we need to find some pattern in these variable in these equations so that we can find out the values of a. So a very common approach to find the pattern is like, let's write some of these expressions and try some operation, addition, subtraction, or something in hopes of getting some pattern. So definitely addition won't work, right? So let's try subtraction. So we have written two expressions for fx and fx plus 1. And if we notice that when we subtract these two expressions, like fx minus fx plus 1, so all expressions, like all coefficients ax plus 1, ax plus 2, ax plus 3 have the coefficient 1. And all terms ax minus 1, ax minus 2, ax minus 3 will have the coefficient of 1. Right? Minus 1. Right? Because we can see that like here we have 2x plus, we have coefficient of 2 for ax plus 2, and here it is 1. For x plus 3, it is 3 and 2. And in on the other side, for x minus 3, it is 3 and 4. So it will be minus 1. So when we'll subtract it, we'll have some numbers with positive coefficient and some numbers with negative coefficients. So again, we can't really solve anything with these equation also. So let's do the same method again. We'll write these twice. Like we'll write fx minus fx plus 1, and then we'll also write fx minus 1 and minus fx. And then we'll try to come up with something from these. So when we write both of these together, what we notice is that most of the part is actually repeating. Ax plus 1 and all terms beyond it, as well as ax minus 1 and all terms before that. They are the same in both of these expressions. The only thing that is different is the sign of ax. So when we subtract these two equations, like this is the equation number 1 and this is equation number 2. So when we do 1 minus 2, so 1 minus 2 is equal to 2ax, right? So with this, we can find out the value for ax. And what exactly will this solve? This will solve our values for a2, a3 up to an minus 1. Now all that is left is a1 and an, right? So I hope it is clear now. Now we know one more thing. What is f1? F1 is a2 plus 2a3 plus 3a4 and plus n minus 1 an. There is no term for a1 here, and we already know the value of all of these expressions a2, a3, a4, and an. So we can get an from this. An is equal to f1 minus a2 minus 2a3 minus 3a4 upon n minus 1. Right. And now we know that in Fn there is no term for An. So it is n minus 1 A1 plus n minus 2 A2 plus n minus 3 A3 and so on to An minus 1. And we can find A1 from this. Like it is pretty much the same, it is just the opposite. So A1 is equal to Fn minus An minus 1 minus 2 An minus 2 minus 3 An minus 3 and so on upon n minus 1. Right. So with these two or three equation, whatever you call them, we can get all values for a. Right. So this is our first equation. This is our second. And this is our third equation. Today was a very tough question. Yeah, today's contest was pretty hard. For D, this is like this is for D it is like for div 3D this is hard, I would say. Definitely this is hard. So let's check the test cases. Here we have 17, 9, 9 and 13. So let's solve this. 17, 9, 9 and 13. So we know that what will be A2? f1 plus f3 minus 2f2 by 2. So this is 9 plus 17 minus 18 by 2. So this is 8 by 2, 4. And similarly, what will be a3? 9 plus 13 minus 9 into 2, 18 by 2. So this is 4 by 2. This is 2. And now we know a2 and a3, right? So what is a4? f1 minus a2 minus 2 a3 by n minus 1. N is 4, so 3. Our f1 is 17. So this is 17 minus 4 minus 2 to the 4 by 3. So this is 17 minus 8, which is 9 by 3. So a4 is 3. And similarly, a1 is fn minus a3 minus 2a2 by 3. So this is 13 minus 2 minus 4 times 2 is 8 by 3, which is 13 minus 10 is 3 by 3, which is 1. So what is our array? 1, 4, 2, and 3. Right? 1, 4, 2, 3. So similarly, this will hold for all of them. I mean, this will definitely hold. We have solved all the equations, right? E was a simple DP on trees, but I'm surprised so many people. Yeah, E was DP on trees. Maybe so many people got it because the DP transition was not very hard. So let's check the code. So we are given Fs, and for all I except the first and last, we can directly find with the help of fi minus 1 plus fi plus 1 minus 2 fi by 2, like what we did here. Right, this is the first equation. And for the other two ones, like for a1, it is fn minus an minus 1 minus 2 an minus 2. And what are these coefficients exactly? These coefficients are nothing but I minus x, right? I minus n, where n is this number. And here this is nothing but, again, I minus 1. And in 1 based, this is in 1 based. In 0 based, this will be n minus 1. And this will be 0. Right? So for a0, we need to do n minus 1 minus I. This will give us the coefficient. And then we are subtracting all of these values from fn minus 1 and then dividing by n minus 1. And for finding out an minus 1, we are subtracting all the values from f0 and then dividing by n minus 1. So this is it for problem D. So let's move on to problem number E now. Oh, sorry, this is F. There is a binary tree of n plus 1 vertices. N is odd. So our total vertices are even with labels 0 to n. At most, one letter can be written on each vertex of the tree, and all vertices initially have nothing written on them. The root of the tree is vertex 0. In the tree, vertex 0 is the parent of vertex 1, and while all other vertices have either 2 children or 0 children. So basically, 0 has a single child, but all other vertices have at least 2 childs, like either 2 childs or 0 childs. And Bob is lost in one vertex of the tree and wishes to escape the tree by reaching vertex 0. This is very easy for most people with common sense. However, since Bob is an idiot, he created a new way of traversing the tree, introducing the idiot first search. When Bob is on vertex V, Bob's movement is determined as follows. If vertex V is a leaf, Bob always moves to the parent of V. Otherwise, check the next few conditions. If nothing is written on V, Bob writes L and moves to the left child. If L is written, Bob overwrites it to R and moves to the right child. If R is written, Bob erases it and moves to the parent. It takes exactly 1 second for Bob to move to an adjacent vertex, so Bob will take exactly X seconds to perform X moves. So this is problem number E. So what we are given is we are given some tree, and like this might have two vertices. Yeah, I'm just making a random tree. And let's say Bob is initially on 4. So what exactly is happening is first Bob will move to the left child and then come back. Then it will move to the right. And now there is nothing written on 7, so it will move to the left, then come back, then move to 9, then come back, then come back to 4, and then go to 3. And now when it goes to 3, it like removes whatever was written on 4. So now when it is on 3, it will again go back to 4. And this whole process will repeat. And then it will come back to 3. Then it will go to 5, come back to 3. Then it will go to 1. From 1, it will go to 2, then come back. Then it will again go to 3. And then the whole process which occurred on 3 will occur again, and then it will come back. Right. And then it will finally reach 0. So this is our idiot first search. And I mean, we can see that this is pretty much DFS, but instead of visiting everything once, we are visiting it repeatedly. And it has been showed that regardless of which vertex Bob starts on, Bob can reach vertex 0 in a finite, though possibly inexplained, very large steps, a very large amount of time. Like we just saw for vertex 4, it is able to reach it, right? And for any other vertex also, it will be able to reach in a similar fashion only. For each vertex k from 1 to n, please determine the total time it takes to reach vertex 0 if Bob has started on vertex k in seconds. As the value may be huge, you are asked to compute with modulo 1e9. And our n is odd, n is up to 3, 5. And we are given the left child and the right child for each of them. And if both of them are 0, that means it has no child. So the first test case is like nothing, I would say. So let's solve the second test case. So this is our 0, 1, 2, 3, 4, 5. And let's solve from the bottom, like from the leaves, because what we can see is like let's say if we start from 1, then also we'll go to 2, right? So let's see what exactly happens when we start from 2. Yeah, the minimum answer is for actually the minimum answer is for 1, so let's start with 1 only. Like if we start from 1, so what will happen? First we'll go to 2, then we'll come back to 1, then we'll go to 3, then we'll go to 4, come back to 3, go to 5, come back to 3. Now we'll come back to 1 and then we'll reach 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 9 operations, right? Is that W due to not using mod? Yeah, I forgot to use mod. That's why I got the wrong answer. Yeah, this one was due to mod. Now, if we go to 2, so from 2 we'll go to 1, then we'll again come back to 2. And then the thing is, when the moment we reach 1, the whole process will repeat, right? So this is like we'll go to 1 and then repeat of 1. So the number of operations are 9 plus 1, 10. Let's say we are on 3. So we'll go to 4, then come back, go to 5, then come back. Then we'll go to 1, and again the whole process will repeat. So it is 4, 3, 5, 3, 1, and then repeat. So it is 1, 2, 3, 4 plus 9. 1, 2, 3, 4. Oh, sorry, it is 5 plus 9. 1, 2, 3, 4. Yeah, 5 plus 9. For 4, we'll go to 3, and then the whole process for 3 will repeat. For 5 also, we'll go to 3, and then it will all repeat. So it is 2, 3, repeat. So it is 1 plus 14. Like it is same for both of them, right? So what we can notice is actually like if we are on some node U, like what we can notice it's let's say we are on node U. Like this is our starting node. So answer of U is some calculation plus answer of parent. Like, can we say this? Like this is what we notice here, right? For 1, we calculated the whole path. For 2, it was just repetition of 1 after 1 step. For 3 also, it was repetition of 1 after 5 steps. For 4, it was repetition of 3 after 1 step. And for 5, it was repetition of 3 after 1 step. Now, what else can we see? 2, 4, and 5, all 3 of them were leaves. So it was 1 plus repetition of parent. Right. If U is leaf, so answer of U is 1 plus answer of parent. But what if U is not a leaf? Like 3 is not a leaf, right? And for 3 it was 4 plus answer of 1. Oh, sorry, it was not 4, it was 5. I don't know why I'm saying 4 again and again. It was 5 plus answer of its parent. It's my CFID. And so my CFID is Sora213. You can like see my ID if you want. It's not loading. Yeah, so for 3 it was 5 plus answer of 1. But how did we get this 5? We know that, like, why exactly were we getting this one? This one was movement of u to parent, right? And this one will come for all vertices, right? So what we can say, say is this is also some 1 plus 4. And this one is 3 to its parent 1. Now we just need to figure out what is this for, or what is this x. Like we can say this is some value x. We can notice one more thing. Like when we are on parent u, and this is, let's say, child 1, this is child 2. So we are going to these childs, and then this is parent. So we are going down, then we are doing all the operations, whatever is happening on the child. Then we are coming back. Again, we are going to second child, doing all the operations and coming back. And then we are going to parent. And then all operations for its parent are happening, right? So what we can say is, can we say answer of u is answer for, like, let's say if there was nothing above C1, like let's say if this was the case, like we have 0 and C1, and then there was something down. Similarly, we have 0 and C2, and some stuff was down. So let's say this is some other variable, let's say answer 2. This is stored in answer 2, let's say. This is the case for answer 2. Then can we say that answer of u is nothing but 1 plus answer 2 of C1? Like this is the left child. This is for left. Plus 1 plus. And there is another one, right? We are coming back also. Answer 2 of C2 plus 1. This is for right. Plus 1 for going to the parent, and then answer of parent as it is. Can we say answer u is nothing but this? Is Sora from Ghost of Tsushima? No, it is from No Game No Life. It is an anime. So this is the profile. Um, let's just discuss the questions first. We will see this later on. Yeah, so this makes sense, right? And also, what was the case for leaf? For leaf, there was no C1, C2. Or we can say that in case of no C1, C2, this was converted to 0. Actually, this wasn't converted to 0. This whole expression was 0, right? This expression as well as this expression was absent for leaf. That's why we were getting 1 plus answer of P. Right. But now let's see for 4. Where it is. Right. I'll draw this again. This is 0. This is 1, 2. This is 3. This is 4 and this is 5. So we need to calculate for 3. right? So let's say this is the case for 4 and this is the case for 5. In this case, the answer will be 1. In this case, also answer will be 1, right? So answer for 3 is nothing but 1 plus answer of 4 plus 1. This is for left. Actually, let's not add this one up as well. This will like create some difficulty. We already know that like what is this 0? This 0 is technically treated like 3, right? So let's say we are saying that we don't need to go here. Like we were getting 1 right. Let's say our answer is 0. Like it is, we are subtracting 1 from the actual answer in this case. And 1 plus 0 plus 1 plus 1 plus answer of 1. So this will come out to be 5 plus answer of 1. And this was exactly our case, right? Where is it? 5 plus answer of 1. So we have figured out this extra part, right? This part is figured out. Done. We don't know about this. Like we don't have answer of 1. How will we calculate this? But isn't there something magical about 1? Like when we were calculating this answer, 2 leaves were good for us because we were noticing what was below us. But when we are calculating the second variable, like for this, we are interested in the parent. For 1, parent is 0. No more operations. Right. So when we'll write this formula for 1, what will we get? Answer of 1 is nothing but 1 plus answer 2 of its left child. Its left child is 2 and right child is 3. Answer 2 of left child plus 1. Actually, let's just write this in a better way. I can write this as, or let's just leave it for now. Plus 1 plus answer 2 of 3 plus 1 plus 1 plus answer of 0. This is 0. And now we need to calculate answer 2 for 2 and 3. For 2, we already know that it is direct, right? This is 0. This is 2. So for this, it is 0. Like we just said, right? We'll do the actual answer minus 1. So this value is 0. And for 3, we need to calculate. So in case of 3, what is this? 3, 4, 5. Isn't this pretty much answer of 3 if there was no parent? Between 3 and 0. Right. And what was the value? For 3, we had 5 plus answer of 1. So if answer of 1 was not present, isn't this pretty much the case? Like we'll go to 4, then come back. This is 2 operation. Then we'll go to 5 and come back. This is 2 operation, and then we'll go to 0. So isn't this answer 2 of 3 nothing but 5? Or can we say that answer of u is nothing but answer 2 of u plus answer of parent, right? We can calculate this easily well from leaf. So bottom 2 of calculation, and like in case of 1 there is no answer of parent. So if we replace this by 5, actually not by 5, 4. That's the whole point. It is 1 less. So let's just add 1 here as well. Right, this was 5, but in this case it is 4. So what we are getting? 4, 5, 4 plus 2, 6, plus 2, 8, plus 1, 9. So this is coming out to be 9. Are you friends with Pradyuman? Yeah, I'm friends with him. I'm also friends with Suvrat. Both of them are from my batch only. Hi bro, can I do your level 1, 2, 3 for CP programming courses with Python? It is generally recommended to do with C++ because most of the resources you will get online are in C++ only, and Python is not very ideal when it comes to time complexity and all. But you can do in Python also. There are now many resources in Python too. But I would say prefer C++. Like, do you have a specific reason to do in Python? Like you can see most of our videos are also in C++ only explaining the solutions. And like for this, first of all, we'll calculate for answer of 1. Then with the help of answer of 1, we can get answer for 2, then 3, then 4, and then 5. So this we'll calculate top to down. Like, is this part clear? Like, we'll try to solve this question properly from this method. Like, this was our tree. 0, 1, 2, 3, 4, 5. So first of all, let's calculate answer 2. So this is for first, second, third, fourth, and fifth. So for 2, we know that it is 0 because it is leaf. For 4 and 5 also it is 0. For 3, it is nothing but like what exactly is answer 2? Let's write that also properly. Answer 2 is of u is answer 2 for left child plus answer 2 for right child plus 4. Like, is this accurate? Because if you notice here, this is like we are pretty much adding 4 ones, right? One for coming down, then going back, another for coming down and going back for both of the child. So it is 4. So for 3, it is 0 plus 0 plus 4. This is 4. And for 1, we can see that it is 0 plus 4 plus 4. Right. So it will come out to be 8. And now what is answer 1? Answer 1 is 1 plus answer 2 of you plus answer of parent. Answer of parent for 0 is 0, we know already. Answer 1 for 0 is 0. Right. So for 1, it is 1 plus answer 2 of you. Answer 2 of 1 is 8 plus 0. So it comes out to be 9. Now for 2, it is 1 plus answer 2 of 2, which is 0, plus answer of its parent, which is 9. So this is 10. For 3, it is 1 plus answer 2 of 3, which is 4, plus answer of 1, which is 9. So 9 plus 4 is 13, plus 1 is 14. For 4, it is 1 plus 0 plus 14, which comes out to be 15. And for 5 also, it comes out to be 15. So basically, we are doing two DFS, right? First DFS is for answer 2, bottom up. And second DFS is our final answer, top to down. In college, Python doing ML, so what should I do it in? I am in first year. Okay, so for ML, you need to do Python only. There's no point in doing C++ for ML. But I'll say that learn both the language, Python and C++. Like these two are the most common languages used, I would say. And do ML in Python and CP in C++. Like I would say it is better to do CP in C++ because it is easy to communicate as well. Like most of the people do CP in C++ only, right? And even I used to do ML in between, so that time I also studied both the languages. Like it is not that much big of a deal. Initially you will have some problem with the syntax and like both the language will just mug up a bit, but after some time you will get used to it. Yeah, so this is the core logic that first we'll calculate the answer to vector and then we'll merge it in answer one. Like these two are the main formulas. Like this is the first important formula and this is the second one. And I would say this was a tricky question because like if you are able to like divide this question into these two parts, then you can get the answer and you can see that these are nothing but DPs only. So let's check the code. So this is our input for child and this is my answer to vector actually. This is answer 2 and this is answer 1. So in the first DFS what I'm doing is I'm going to if the children exist, I'm going to the left child as well as the right child. And then what I'm doing is I'm just adding their values and then I'm adding 4. Like this is what we are doing, right? Answer 2 is answer 2 for the both the childs plus 4. And in the second one, what we are interested is we are interested in the answer of parent. So you can see that I haven't made a parent array because like we can skip that step. Whenever we are coming down, we already know that, for example, here we already know that the parent is you. So instead of making a like a vector for parent and storing like using that, what if I just use a variable like val? This val is nothing but my answer for the parent, right? And then I'm passing this val on right here. And you can see that I've done this plus one. This plus one is nothing but, right, this, which I've added here. I've done this in DFS call only, during DFS call. This plus one is due to that, and then I'm just adding the answer to this is my move, the move vector. Like, don't really ask me why did I name this move. And this is my current answer, and I am storing it in a variable so that I can use it for its children. And basically, this gives us the answer. So I feel this was a bit tricky question, but it was fun. Yeah, let's move on to F. So now again, this is a mathematical question. Parabola independence. You are given a set of n quadratic functions f1, f2 up to fn, where fi of x is equal to ei x square plus bix plus ci. Basically, we are given n quadratic equations. And two functions f and g are independent if fx is not equal to gx for all values of x. So f and g are independent if they don't intersect. Like, we can say that, right? If no intersection, right? Like, suppose this is f and this is g. So here there is intersection. So not independent, because for these two values of x, they will come out to be equal. Similarly, this is also not independent, or this. Like, all these are not independent, right? Also, a set of functions g1 to gk is called organized. If two functions gi and gj are independent for all values of I and j, and for each I from 1 to n, we need to find the size of the largest organized set of f that contains fi as element. So basically, we need to find the largest set for each of the elements, like whatever we can get. And our coefficients are from minus 26 to plus 26. N is small, 3000, and n square is up to 3000 square. So this is 96. So that is n square will easily work, and we are given 3 seconds anyways. N square will work, n cube won't work. So potentially n square. Like, all the problems till now are either O of n or O of n log n. So this is O of n square. So what exactly can we do with this information? Like, first of all, for each pair of I and j, we can check if these are like intersecting or not. Like, for all pairs, can check intersect or not. This will tell us whether they are independent or not. Independent or not. So this is possible because this is again O of n square, right? Now, what exactly can we do from this information? We need to find out that. And like this is the first test case. Here we can see that for F1, we can choose F1, F4, and F3. There are no intersection between these three, so answer is 3. For F3 and F4 also, the answer will be 3 for the same 3. But for F2, we can only select F2 and F1, so the answer will be 2. Right. But I don't feel this is very helpful. Like we can't really figure out anything from this, right? So let's try if we can figure out something. So F and G are in a set if they are independent. So what happens if they are independent? If they are independent, then fx is not equal to gx for all values of x, right? But let's say for x1, f of x1 is less than gx1, and for x2, f of x2 is greater than gx2. Now my question is this possible? We know that f and g are independent. Like, is this possible? Actually, how many of you solved f or did some progress in f? Because there were still a lot of solutions up to E, but for F, there weren't many solutions in the during the contest. Yeah, so let's say this is a curve. Like, what are the possible ways for no intersection? We already saw for intersection, but we didn't really bother about no intersections right that time. Let's say this is first curve and this is second curve. Just give me a second. Yeah. So here there is no intersection, and we can also see that let's say this is F, this is G. So fx is actually greater than gx for all values of x. How about a curve like this? Here also it will be the same. How about both of them are like pointing towards up or down? Let's say this is our first curve and this is our second curve. In this case also f is greater than g for all values. Like if you draw some curves, you can notice that this condition is actually not possible. This is not possible. So if f and g are independent, fx is less than gx for all values of x, or fx is greater than gx for all values of x. One of them will definitely hold. Right. Now let's say we have three curves, F, G, and H. And let's say we know F and G are independent. F, G independent. And F is less than G. We also know that G and H are independent. And G is less than H. Let's say we have this information. Then we can definitely say that F is less than G is less than H, right? So does this give any hint? Like, let's say for a curve G, we know that G is greater than F. Like G is greater than F1, G is greater than F2, G is greater than F3, and so on. And let's say we also have some curves H1, H2, H3, and G is less than these curves. And let's say we have taken out the answer for these F curves and H curves. Like we know the answer for F1, F2, F3, and H1, H2, H3 are known. So can we find the answer for G? Like, can we find it? Since we know that if all F's are less than G and all H are greater than G, can we say that all Fi are less than G and these are again for all possible I and J pairs? And for a certain pair, what will be the answer? Like if we select this pair, so if we select set Fi, G and Hj, let's just suppose. And since we were saying we know the answer for F and H, let's also say we know answer if like we know a set, we know answer if F was largest, and we know answer if H was smallest. H was smallest in the set. Like let's say for F, the set was something like A1, A2, A3 up to F. And here what I'm saying is A1 is less than A2 is less than A3 and so on F. Let's say we have taken out this value. And for H, H1, B1, B2 and so on. And we know H1 is less than B1 is less than B2. Let's say this is smaller set, like smaller count, and this is larger count, right? If we know both of these sets, then what is the answer for F? Sorry, what is the answer for G? Won't it be just answer for F plus, sorry, uh, won't it be nothing but answer, like answer for G will be nothing but smaller one for F plus larger one for H plus 1. Won't this be the answer among all possible F and H? Like, we need to take the max, right? So now let's say we sort the, like, how exactly we'll know whether a curve is smaller than or larger than another curve? Like, it's not that easy, right? This is our curve. Fx is equal to, let's change the pen. Like, what is Fx? Ax square plus bx plus c, right? Let's take two curves, for example. And let's say f1, f2 are independent. Then can we say that if a1 is greater than a2, then f1 is greater than f2? Can we say this? Because if a1 is greater than a2 and let's say we put a very large value for x, then x square will be very large. So whatever is the value of b and c, like let's say we put 100 or something, right? So at some point or the other, x square will dominate. So a is the deciding factor, right? Like a is the deciding factor, right? And again, how do we know if two curves are independent or not? If f1, f2 are independent, then if a1 is greater than a2, then f1 is greater than f2. Like this is definitely true, right? But what about f1, f2 independent or not? How do we check this? F1 should not be equal to f2, right? Or we can say f1 minus f2 is never equal to 0. Or you can say a1 minus a2 x square plus b1 minus b2 x plus c1 minus c2 is not equal to 0. Or no roots. So what is the condition for no roots? Let's say this is a, this is b, this is c. So d is b square minus 4ac b square minus 4ac should be less than 0, right? B square should be less than 4ac. This is the condition for independency, right? So what we can actually do is sort all f's f sorry, sort all fi's on the basis of their coefficients, on the basis of a b c, right? Like first preference is a, then b, then c. Like if a is equal, then we will check b, and if b is equal, then we'll check c. Actually, there's one more condition here. What if this term is 0? This is 0, let's say. Then if b1, then this is a line, right? And a line always intersects the x-axis. But what if b1 is equal to b2? Like this is also 0, let's say. What is this is 0 and this is non-zero? This is another condition. So this is condition number 1. And what is condition number 2? a1 equals to a2, b1 equals to b2. And actually, we are also given that all the curves are distinct, right? It is guaranteed that the function in one test case are pairwise distinct. So if these two are equal, C is definitely not the same, else it is the same curve. So these two are the conditions for independency. And we know that if two curves are independent, then if A is greater, then F is greater. So what we can do is, my bad, sorry. Yeah. So what we can do is, we can sort all FIs on the basis of ABC. And then while we are iterating, like left to right, what we can do is we can find the answer for us, like we can find the smaller answer. We can calculate the smaller count, right? Like small for a function I is nothing but 1 plus small for a function j and max among all of them. And when we will consider this, if fi and fj are independent, right? And similarly, large count is also same. In this, we'll go from right to left. Large of I is equal to max for all j's. Max for all j, 1 plus large j, right? And once we have gotten these two values, now what do we need to do? Once we have gotten these two values, all we are interested in is in the answer. Like what is the answer for I? Answer for I is nothing but number of small values plus number of large values plus 1. Like we are considering this also. These small and large does not include themselves. Actually, let's say small and large includes themselves. Like this is, let me put this down. Like I'll explain it 1 second. Like for I, what is small I exactly? Small I are some curve like f1, f2, f3 up to gi. Right, this is the set. And we know f1 is less than f2 is less than f3 is less than gi. Large I is g1, sorry, gi, h1, h2, h3, and so on. And gi is less than these. So basically, when we'll add both of them, g will come twice, right? So we need to remove this one. That's why we are doing -1. Or in case we are calculating small and large without g, like number of, like it is a set without g, like up from f1, f2, f3, but g is not there in both of them. In that case, it will be +1. So this will give us the answer, right? For each j, we just need to check whether they are independent or not. And if they are independent, then we are good. Else, there is an issue. And we already saw that we can sort these. And the whole point of sorting was that we already know that either the entire f is greater than the other f or entire f is smaller than the other f, right? So this is the helping point. Like this was important. So any doubts? Okay, let's see the solution. So I made a struct so that it would be convenient to like deal with A, B, and C. Like pair was very annoying, and vector was also annoying. So I just created a struct, and this is our function. And now since we need to sort and we need to answer for each of them, so index is also important. So what I'm doing is I'm creating an index variable, like index vector, where index of I is equal to I, and then I'm sorting them. Like this is the comparator function. Like if A's are different, then I'm sorting on the basis of A. If A's are equal, then I'm sorting on the basis of B. If B is also equal, then I'm sorting on the basis of C. And then indexes are sorted, and then when I'll do f of index, then it will give me the corresponding function, like the smallest function. So what is the calculation for before? What I'm saying is if, like, let's say the current answer for, let's ignore this part for now. Let's see the valid function. What exactly is valid function doing? We are taking two functions. This is f1 and this is f2, right? And here what I'm assuming is f1 is less than f2. Like we can see that j index comes before I, so index j was here first. But when we were calculating for the larger values, we are taking index j afterwards because j is greater than I in this case, right? So we are first of all ensuring f1 is less than f2. Now let's say again we are checking the condition of independency only. Like what was the first condition? If a's are equal, b should also be equal. So if a's are equal, then b should also be equal. If b is equal, then they are valid. They are independent. Else they are not independent. Like this is to check independency, right? And now if a's are not equal, then I'm calculating the difference a, b's and c's, and then if b square is less than 4ac, then these are independent, else these are not independent. Now let's say f1 and f2 are independent. Now among all independent pairs of f1 and f2, what is small of I? Small of I is 1 minute. Yeah, small of I is maximum of 1 plus small of j. So I need to take the max of all possible j's. So what I'm saying is if the current value of small of I, like let's say like current value of small of j is greater than equal to small of I, then definitely small of I is less than small of j plus 1, right? So small of I will be equal to small of j plus 1 in this case, right? So this is exactly what I am doing with this condition. Like if before j is greater than or equal to before I, then as well as they are independent, then I am incrementing this. And the same loop is running in the backwards direction for after. And as you can see that I've initialized them with 0. So if I don't find any function smaller than or greater than them, then before of I will be 0. And we know that 0, like what exactly is 0? That means we aren't taking the function itself either, right? So that's why we are taking this plus 1 here. Like here we have taken minus 1, but where is it? Yeah, here we have taken minus 1. I don't know why this is lagging so much. But you get the point of minus 1, right? Like in case if I change this to 1, in this case it will be minus 1, right? Oh, sorry. Not here, here. And this is it for F. So I hope you understood the problems and it was a great session for me. The contest was a bit hard than regular div 3s. Like the F was also particularly hard and E was also not that easy, right? So any doubts? Okay, so I'll be ending the session then.